So last up at this session is Görel Hedin, very welcome, at the Faculty of Engineering, Lund University. And Görel will present the SMARTY project, which is about secure deployment of software updates in the context of smart cities.
Thank you very much. Yes, so our project is focused on what happens when you have the smart city with lots of different devices and software running on these different devices located in many different places. And you need to update the software in a quick and automatic way. For example, you've discovered a new vulnerability, so you need to push this out. And these devices could be, for example, I don't know, lamp posts, traffic lights, bikes, all kinds of things out there. This is joint project between two departments at Lund University. It's funded by SSF. Let's see here. So the main goal is then how do we deal with these updates? And we're doing research in various areas related to this overall setting. So one area is vulnerability analysis. So trying to find out or manage how where are the vulnerabilities, what code needs to be updated, and so on. How should we prioritize things? Device management, how do we actually deal, organize the devices and the software that's on them? How do we program them so that they're easy to update? Network security, using, for example, trusted computing, and also new applications using cryptographic primitives. And we're building demonstrators, and in particular, together with Helsingborg City. So a little bit about our participating partners. So I'm Görel Hedin, I'm the project lead currently. Boris Magnusson is sitting down there. We're from the computer science department, so we have more of a programming language and software architecture background. From the EIT department, we have Paul Stankowski-Wagner. I think he's here, but I haven't seen him. Christian, who you just heard, who has another project. So they're from the security group. So we're sort of merging these different disciplines in the project. Now, last year we had actually some people leaving the project to do things, security work in other places. Let's see. Oops, that's too fast. So Martin Hell, who was previously leading the project, he's now left the university and is at Debricht in industry full-time, working on software vulnerabilities in open source software. Elena Pagnin got a position at Chalmers in the security group there. And Nicola Palladi, I think he's here, but I haven't seen him. He started his own company, CanaryBit. He was a postdoc in the project. So to give you a little bit overview of some selected results in these different areas. In vulnerability analysis, there was one piece of work done here in looking at GitHub issues. So just looking at the text there and trying to find out if this is security related or not using machine learning techniques. And this was a collaboration with Debricht, so I think they're building further on this now in industry. Another example is that we're working on a new kind of source code analysis based on demand-driven algorithms. So this makes it possible to write client analysis, for example, for vulnerability in a very efficient way. And a recent result here is actually in debugging those new analyses in a way so you can interactively look at source code and look at detailed results in sub-analysis and change the source code and see the new results immediately and so on. Now, the core of the project is perhaps device management for how do we actually program these systems to make them easy to update. And here we have developed a domain-specific language to be able to more easily construct new systems. So the idea here is that you have devices at different locations, different lampposts or whatever. You have service software running on these devices. But this service software is sort of black box components written in any language. And they have an interface here So they don't really take any initiative to set up connections elsewhere. Instead, we have a domain-specific language where you can script components or compositions that connect these different services and mediate the messages between them. So this way we have a high-level language here, making it easy to analyze the whole architecture of the system. We have deployed these techniques in a collaboration with Helsingborg City, where we built small applications for bikes. The people working for the municipality there with home care, they are like, you know, going out to hemtjänsten, biking around to different people to help them with daily life, pensioners and so on, or retired people. So they use bikes, and the batteries get stolen all the time. So we made a small application that can check if batteries are stolen. Now, of course, that's just one application, and the application as such is perhaps not the focus here, but the focus is what happens if the software here needs an update. So a vulnerability was found in some open source library, and you need to update the code on running on different bikes or different equipment in the patient's homes or whatever. So we had a demo of this using real bikes at the H22 City Expo in June. And we're continuing working on this. So one of the parts here is to have configuration, so we know exactly what software is run on exactly what devices, and we can update them gradually in a controlled way and automatically and so on, without having to go to each bike and do something. We also have collaboration with a company called Hitachi that make healthcare solutions. And they have similar setups where you have a lot of equipments in different places that you need to coordinate and update the software and so on. Where should I point this so it works? That way? Yeah, okay. Yeah. Okay, so some results from network security. So that's where we have looked at how you have untrusted components who need to call a trusted enclave inside a computer, and so you use enclaves to separate out so that you can do secure things here. Well, this communication or these calls can be quite expensive, so there's work here on making that more efficient by using a library. So the untrusted code here, instead of calling directly, can call this library. And the library can, for example, batch several calls together or use more faster techniques using shared memory for some kinds of calls. In the application area, an example result here is for more efficient cloud storage. If we have many clients here who store things in the cloud, they all encrypt their stuff. So how can the cloud storage provider then take advantage of that much of this information from different clients is actually the same? Can't do that if it's encrypted. So the idea here is to have a third party that can keep track of different chunks of data and their fingerprints, and that way avoid storing something too many times in the cloud, so you save storage, making it more efficient. Okay, so that was a very quick overview of different things we do in the project that all contribute to smart city and updates. And if you want to know more, we have the poster. We also have a site here where you can go and watch videos of different parts of the project. Thank you.